Hi, welcome to the panel, Security is Not a Unicorn. We're here to talk about security in HPC, and we've got a great panel, so I'd like to let everyone just introduce themselves and you'll understand why we're here. So Ava, why don't you go first?
Okay. Hi, Jay. Thanks. So my name is Aeva Black. I've been a systems architect, developer, admin, database admin for on and off about 20 years now, and in open source for about 15 of that. About 9 or so years ago, I started working on OpenStack and ended up building and running the OpenStack Ironic project, which served a lot of HPC, a lot of bare metal users. That was sort of the initial products that we launched at HP with that. Now today it's used in CERN. So I learned a lot about the intersection of cloud and HPC back then. And today I'm working at Azure in the confidential computing department, where I'm working a lot more with security stuff.
Excellent. Marlo, why don't you go next?
Hi, my name is Marlow Weston. I have worked at a variety of different companies, including HP, National Sandia Laboratories, Redstorm, and now at Intel at the HPC Tools Group. And in that time, I've done all sorts of things from embedded all the way up in security. And I started looking at Kubernetes about a year and a half ago and how it interacted with HPC and ended up here.
Cool, cool. I'm eager to learn. Sarah?
Hey, my name's Sarah Young. I'm a senior program manager at Microsoft Azure, so I do security engineering stuff. I've been working in infrastructure engineering for my entire career. I really love Kubernetes containers and how we do security better in a cloud-native environment. So yeah, really excited to be here.
Awesome. Marlo? I'm sorry, Marlo Trupti.
Hi everyone, my name is Trupti. I'm a mobile game developer turned security professional with more than 13 years of experience in software security and applied cryptography. Currently, I'm working as a principal application security engineer at a security startup known as Illumio, who builds microsegmentation products for data centers and endpoints. I came to this panel because I'm extremely curious about high-performance computing-based applications and systems, their role in making the humanity better, and the unique security challenges HPC systems face. While mitigating these challenges and threats, the discussion around how to strike a balance between performance and security fascinates me, and that's exactly why I'm here.
Awesome. Well, I'm Jay Beale. I'm going to be moderating today. I'm the CTO over at InGuardians, and we do a ton of Kubernetes penetration testing and other kinds of security work. And I teach a Black Hat class that involves attacking and defending Kubernetes. And I'm here to learn. I'm here to learn how security and how security's a challenge in the HPC world. And so I'm really eager to start. So, well, let's take it away then. So we're here to talk about the challenges that come up in high performance computing, or HPC. So why is this difficult enough that you've come to a panel on it? What kinds of technical challenges does HPC put on the standard Kubernetes security practices or the best practices?
I can take some of that. So HPC, classic HPC, you have a front job scheduler, and you go past the job scheduler, and that's where the jobs are run. So unlike cloud native, where everybody has access to their pods, you don't have access to your jobs while they're running. Like, you can look at log files, but you can't access the job actively. In cloud native, it's a completely different format where you can access. And when you start looking at, say, networking or storage, it's the layout and how it works in cloud native is very different than how it works in HPC. So in cloud native, you have namespaces and C groups. You don't have those with classic HPC. And additionally, when you're looking at, for instance, your CNI, your network layer, you don't have access to that either in HPC. So you can't just go sniff the traffic going around. And also, your job is scheduled for particular nodes. You're not going to be there listening to other people's jobs that may be on the same node. So when you start looking at those things and you add encryption on, you realize, oh my goodness, look at this performance that I'm getting just on getting the network if I want to do encryption. You have a much different world.
Yeah, absolutely. It sounds like Kubernetes is creating a lot more capability, but it's also creating a lot more. It's also destroying some of the assumptions that have existed in HPC. Is that right?
Yes, very much.
Cool. Well, so is Kubernetes solving a unique technical problem here? I mean, as we look at how you do security in a high performance computing environment, like we've kind of heard where things have been traditionally. Has anybody tried to solve this problem before?
Take that one. Yeah, OpenStack went through a phase as it started to mature, and a lot of existing companies or data science places started trying to use it for large workloads. I had one time, sort of the early days of that, I was at one of our conferences, and a grad student, someone ran up, looked like a developer, and said, I'm a grad student at, I think it was University of Madison, and our entire, if I remember correctly, our entire cancer research lab is running now using Ironic with just 3 people. I don't know, 1,000, 2,000 machines. It was a big cluster. Really impressive numbers. And we talked a little bit about the workload, and not a typical workload that we'd see on a cloud back then or today. Jobs were scheduled differently. And I learned a fair bit then about, how the job scheduling is quite different than in a normal cloud.
Gotcha. Yeah, I'd like to understand, how things are different. Like, what are some of the, let's get a little practical. What are some of the workload types that are unique to HPC? We talk about high performance computing. What is that?
Machine learning.
Okay, absolutely.
One of the example I could think about is astrophysics or scientific computations happening on corona vaccine data.
Yeah.
Well, that's timely.
So you have a few different types of jobs, right? So some of them are very much what's called embarrassingly parallel. And when you say embarrassingly parallel, you can split it up into a whole bunch of little jobs, and they kind of run independently. They don't have to talk to each other. And then there's ones where you need communication in between the different components to do each step. So a lot with machine learning as an example, for training, they have to talk to each other. It's a distributed computation. When you're talking inference, it's not. With astrophysics, there's some jobs that'll be one way and some that'll be another. With the HPC, the ones that become challenging are not the ones that are embarrassingly parallel. They're
Sure.
the ones that involve the communication.
Right. So we saw a lot of folks trying to add to OpenStack hardware support to accelerate that sort of network communication using PCI pass-through or SSL offload cards or TCP offload cards to get more parallelization of workloads as they're communicating across nodes. And today we're seeing similar stuff around cryptography.
Well, it sounds like you might have a lot of need to have really fast communication on those non-embarrassingly parallel ones. You'll need a lot of fast, low latency communication between parts of the workload. Does that mean the schedulers are trying to keep a lot of the job on the same, on the same set of machines, whether those are like in the same data center or maybe even on the same machine?
Yeah, so some work was done in the OpenStack scheduler, which was eventually made pluggable. And people were able to build different scheduling algorithms for different types of workload. HPC folks who are doing that, last I heard, had really customized their schedulers to optimize locality as well as fault zones and proximity network-wise or latency-wise for their workloads, which is not something that's as important in a public cloud.
Wow, I'm finding myself really wanting to learn more about that, but I guess we're on the security, we're in a security and HPC panel, so I guess I should focus us there. So, okay, so Kubernetes security is just by itself a rather hard topic. There are lots of sessions at this conference talking just about security. We're all having at times really strong assumptions about how much security is already baked into defaults and then running into that hard. Does HPC make these security the security goals and using those controls more difficult?
I'm going to have to jump in here, seeing as I've been quiet so far. So, okay, so you're right. There are tons, and throughout the whole of this conference, there's going to be heaps of talks on how you do Kubernetes security well. And I think my comment here, rather than specifically on HPC, is to remind people that I don't think we know how to do Kubernetes security super well yet. I don't think anyone does. You probably know yourself, Jay, from pen testing Kubernetes and things, that people don't always set it up amazingly well. So if we don't set up our Kubernetes well, and then we're going to run an HPC environment on top, in my opinion, it can only add additional complexity. But I just think my point is that we shouldn't just, when we're talking about this question, don't forget about what's underneath, because I don't think we've really got 100% there with what's underpinning this HPC, and then we're going to have to put some more on top. I'll let someone else chime in onto specifically what you may need to consider for HPC, though.
Or it sounds like also the challenges of what you don't get to have potentially.
Well, yeah, exactly.
That's what I'm worried about.
I would like to jump in here. First of all, I would like to say that just focusing on Kubernetes security is not sufficient to protect entire end-to-end stack of HPC. While Kubernetes is super important and we need to secure it because Kubernetes is kind of the default deployment mechanism in native cloud, as well as it's the part of infrastructure, we also need to take a look at the application security side of HPC. We need to make sure that the existing architecture and design kind of meet the business goal through technological means. We also want to make sure to perform activities like threat modeling. Who are our threats? Who are the threat agents? Are we actually protecting our HPC against those threat agents? And I would like to mention here, recently we just saw how foreign state actors are targeting US biotech firms who are performing research on COVID-19 vaccines. So are you actually protecting your HPC systems against those relevant threats? If not, there is some soul searching we need to do there. Besides threat modeling, I also want to mention about the code security. Are you making sure the code that goes as part of HPC, you are securing that, and not just code, but the third-party open source libraries, framework, because a simple vulnerability in a third-party library can create a big security impact. Do you guys remember the unpatched struts server resulted in Equifax breach? Yeah. Lastly, I would like to say that get your HPC systems externally pen tested using expert third-party vendors such as yours, Jay. That's also extremely important, because you never know what kind of findings these creative pen testers will come up that blue team may not able to identify in timely fashion. So while for traditional non-computing HPC system, setting up and typical application security program is quite a standard practice. That's not the case I have seen with classic HPC. So we might want to pay attention there.
Yeah, it sounds like some of what you've brought up just now is, especially when we're thinking about the recent attacks trying to get COVID vaccine work, HPC environments that thought of some of the risks as a little more theoretical, or things that happen rarely enough that maybe we can kind of put that off till later. It sounds like that might be coming up a lot right now.
It's a juicy target.
One thing I'd like to jump in with is when you start talking about libraries being compromised, you have to be careful with HPC because these are real scientific numbers coming out and you don't want to change your numbers. So if someone upgrades a library and then while they're at it, fixes some sort of math function, suddenly your numbers are different.
So in this case, I can think about a security trade-off, like instead of upgrading the libraries to the latest, greatest security version, which can introduce a diversion or performance hint, we can think about access control mechanism so that we can limit the exploitability factor to that vulnerable library. In this way, we do a security trade-off to make sure HPC system is secure and intact.
Trupti, I think you're talking about software supply chain management.
Yes.
Okay. Yeah, I think that's really important. And in HPC workloads, not as Marlow was saying, not just upgrading automatically. In Kubernetes, we might rebuild our image for every deployment. Rebuild might be kind of automatic. In HPC, it's really not the norm to rebuild on the fly. There's often, I've seen a change control process, a lot more auditing or inspection of the image build process that goes into that might, even in a research setting or university, be done. Same thing might also be done in an enterprise, but it's not sort of cloud native.
Yeah, absolutely. And I know, Aeva, you've done a ton of work in software supply chain. Marlow, what you've said scares me a little bit, like just realizing that when you're looking, when you've got that standard, when you're doing science and clinical work, you've got to get the same darn numbers every time. And so library upgrades can be dangerous, but often that's the only way a patch happens. Wow. Okay. So I think we can talk about different kinds of controls, and I'm kind of eager to hear what helps the most. But I keep thinking, from what you've described, Marlow, especially when you talk about the way HPC has traditionally been done and how things get a lot different when you bring this to Kubernetes, when you bring it to cloud native, that it's going to be a different cultural. Well, it's going to be a different culture. So, in addition to the technical challenges, are there cultural hurdles to bringing security to HPC?
Absolutely. I mean, usually HPC people aren't used to thinking about security except for that the front job scheduler, right? They're not thinking about all the other pieces. And when you start talking about Kubernetes, especially since a lot of the people have been in the field for 30, 40 years, you see them freeze up because it's a completely different model. But what you do see is a big push with the younger generation because they don't want to have to sit and think about how all the things are compiled on their individual system. Because often with the HPC stuff, it's compiled for the specific system they are running on. And whereas in containers, you can expect, a certain type of computation because it's a container. It's statically built often with libraries. If you're using Golang, for instance, a lot of the ML stuff, the AI stuff, they're going more and more towards static libraries. So it's just a completely different world. And so you see a lot of headbutting as far as people going back and forth. However, some places, and I believe Aeva knows more than I do, have moved towards more cloud native type environments, starting with OpenStack.
I mean, some places may have, doesn't mean they didn't struggle or run into some of the same things we're talking about, Marlow, folks being like, well, but this is how we've always done it. Why can't I do that now? Or, transposing their prior assumptions onto a system like OpenStack or Kubernetes, and those assumptions mean they're not doing the right security checks anymore.
I'll just jump in there too, because, this is, as Aeva was saying, this is something that comes up time and time and time again. people take when you introduce something that's new or it has a different structure, or it's brand new technology, whatever, often people will take old security rules and apply them to the new technology. Whether or not that is valid or not, it's just what people tend to do. They're like, oh, it's basically an application, so we'll just use all the same tools, controls, etc., and it'll be fine. And you inevitably end up with gaps. So I don't even think I know we're talking about it with an HPC lens, but it's something that we see time and time again. If it's and that's why security is so hard, because it's not just the technical side of things. In fact, is probably easier in a way than the cultural things, the cultural changes that have to happen, whether it's a team applying old principles and technologies, or it's a team like Marlow was saying that has never had to do security before, so they don't see why it's relevant. It's a massive, massive, massive challenge. Really, really, really tough.
I would say, you know, we all being the security champions, we need to be the change that we would like to see in our teams, departments, or organization. And I can't put enough emphasis on educating all stakeholders, not only the technical developers or scientists, but the business folks as well, on the impact of breaches through, you know, security awareness training, by empowering them with the right tools. In this case, there are tons of open source security tools available that we can integrate in Kubernetes CI/CD pipeline. In that way, security doesn't become a hindrance for their innovation all the time. So by doing that, we kind of giving our people a chance to change. And when they know the change is kind of coming from a caring heart, where we understand their pain points, their business deadlines, they get it. They don't necessarily feel challenged.
Makes sense.
You mentioned tools, and I wanted to bring up some tools. Right, I've seen in the hardware space, which is sort of my playground, several years back, we had a lot of work in OpenStack, and I know Kubernetes has done similar, around PCI pass-through and NUMA topologies or NUMA-aware schedulers to take advantage of specific types of hardware. We see the same thing with GPUs for machine learning and HPC. SSL offload, mentioned that. We're now seeing, right, and yet another tool with SGX or ARM trust zones, right? Hardware trusted execution environments or enclaves, creating a sort of partitioned section in the processor to do computation so that it can be encrypted in use, in addition to encrypted at rest and encrypted in transit. And so I think we have, you know, every couple of years, new tools are added to the tool belt of security experts specifically in the HPC space.
Yeah, I'd like to talk about tools a little bit. That sounds really nice. The secure enclave, just, you know, for those of us, you know, for whom that's pretty new stuff. Secure enclave basically gets us to the point where I can have multiple workloads, multiple high, you know, is this like where I could have multiple privileged workloads on a system and they wouldn't be able to see each other, or they would be able to snoop on each other, as it were?
In theory, a virtual machine boundary does that. But the VM boundary isn't protected from a malicious root user or malicious firmware on the host, whereas a secure enclave is, right? Even if your neighbor, someone pops out of their shell, pops out of their VM, gets root on the host, the enclave is still protected because even the root can't access it. Nice.
Well, cool. Let's talk about other tools, or let's talk about, honestly, I want to understand where you have to make the trade-offs. You know, where are the places where we just say, well, okay, so you're in a PCI environment, you're required, so that means you're required to encrypt all transport. Is that a difficulty in HPC? Like, where do things get difficult here?
So classic HPC, it's not a problem because you don't have to encrypt the traffic and transport. Right now, if you look at the CNIs, there are two, Calico and WeaveNet, I believe, that have encryption enabled. Your performance tanks. So they're not really good options for doing encryption at this time. So if someone, no one has yet, and I'm Intel, uses something like the QAT cards, which are on the PCIe bus, and uses that for your encryption layer through one of these CNIs, you can get better performance. But no one's done these things yet because that hasn't been necessarily a thing they've been looking at. Kubernetes is still fairly new, so we don't have as advanced tools as you do elsewhere.
Gotcha. So where are other places where there are challenges or you have to make trade-offs? Are there any cool tricks or tested techniques you found that help here?
So one of the example I could think about is when you're processing terabytes or petabytes of sensitive information, performance is extremely important for latency sensitive application. One of the example I could think about is, let's say, a simple credit card search operation where you need to decrypt billions of encrypted credit card information, match the right credit card record and return that information. In this particular scenario, just the simple operation of decrypting billions of credit card, it's going to give a hit from performance perspective. Now we have a couple of ways to deal with this situation. The first thing I could think about is you can keep your credit card information in plain text information and really apply strong access control to prevent any unauthorized access, maybe using some of the microsegmentation technique or role-based access control technique. But in this case, you meet the performance, but you're losing on compliance and security, but you make that trade-off. Another thing I can think about is you can go more security innovative side where along with storing the encrypted credit card information, you also store a simple HMAC SHA-256 tokenized value and perform your searching against the tokenized value, which is faster and will not give you any performance penalty. In this way, you don't have to worry about any security trade-off and you still meet your performance as well as security requirements. So in HPC world, it's really going to vary from application to application, case to case, depending on the architecture and business use case, I feel, Jay.
Yeah, and just to add to that, I mean, when we talk about trade-offs, we always talk about trade-offs in security. I mean, all the time. So, and I know that particularly technical people will roll their eyes a little bit when I start talking about saying, you have to assess the risk, and it's a risk-based approach, but it is the reality. So, you know, whenever we make technical decisions in security, there's often a trade-off. So if I do this, either I spend loads more money or performance is going to take a hit, and it's always a risk-based decision. Now, I'm not saying that people who are listening to this necessarily need to make that call. Like, push it back to your security teams, and some businesses will have special technical risk teams whose job it is to make the decision on behalf of the business. Certainly, you want someone who gets paid enough to take responsibility for that decision, which probably isn't a technical person. But what you can do as an engineer or an architect, someone helping with that, is help the risk people and the decision makers understand the pros and cons of each decision. You know, if we do this, you know, it might be more likely that this attack would happen, but we're saving $10 million or whatever it is. And companies make those trade-offs all the time in security. And I don't think it's a bad thing. It's just life. But as long as all the decision makers are well informed and know the facts of, you know, what's the likelihood of this happening? What's the impact? I think that's the best we can do. And I do think that, I'm not saying anyone here go away and learn risk management. Please don't. But we do sometimes forget that as technical people, we do have a responsibility to help non-technical stakeholders and decision makers understand what they're being asked to choose between. I do think we forget that. And again, HPC and everything else in security, but I like to talk about it because it always comes up.
That sure makes sense to me. It sounds like there's a lot. It sounds like HPC puts us in a much more complex place. As somebody who, you know, somebody who's playing the attacker almost all the time, I'm lucky enough that, and I think a lot of security people are like this. I'm lucky enough to just say, you should do these 10 things if you want to stop what I just did, and not have to consider what those trade-offs are and why, when I come back, they didn't do some of those, or they made different, or they chose compensated controls or what have you. That sounds like this gets, like it's important everywhere, like you're saying, Sarah, and maybe this gets more complex in an HPC world.
I think so too. And as I said, ultimately, some people who ultimately make the final call or at least take responsibility for what decision is made there, they're getting paid a lot more than I am. So, you know, and that's why ultimately you take more responsibility as you go up the chain. But as you rightly point out, the more layers of complexity, because I've just been doing very this or that decisions. In reality, it might be this or that or that or that or that. But there can be lots of different options.
Wow. Man, I have a lot to learn here. Okay, so as we think about this, as we talk about this, I just keep coming back to that question of the, you know, of how the culture is different, and also how you know, Kubernetes and cloud native has made things different for the HPC folks, and for all of us, and how much it changes. So what I'd like to ask is if you could give one piece of advice to HPC folks who are really looking at security beyond, you know, beyond their traditional model for the first time, or if you could talk to security people who are having to deal with HPC for the first time, like what would you want us to learn and share? What would you share?
You know, it takes a village to build a good security program, and it takes time. Change is hard, so we need to be patient. And if I have to answer your question, what is that one thing that I would like to implement to make sure HPC systems are secure is shift your security towards left as much as possible to build an agile, scalable, holistic security program.
And just building on that, to me, like, no one does, like, it's really, don't beat yourself up if you don't know security, especially if you're just coming into it for the first time, because everything, the rate of change in cloud native and other technologies is so immense that it's actually normal not to know everything. And that's the same for security as well. So I think it's really important that, you know, people don't beat themselves up if they don't know everything, because I do think that we have a little bit of a culture problem sometimes in technical spheres where it's like, oh yeah, I know this, I've never done it before, but you know, to admit that I don't know this is seen as like throwing shade on my technical ability. So I won't say I don't know it, and I'll just try and muddle through. Security isn't one of the things where you want to do that, and I actually wouldn't like recommend that approach for any kind of technology, by the way. But you know, if you don't know something, that's okay. Go and ask for help, reach out to the community, reach out to specialists, because there's always someone else who will know it at least better than you if you need help, and that's okay. And I have seen people get, and organizations get into real muddles, for want of a bit, for want of a nice phrase for a recording, because they haven't done that, and they've just muddled through and without really knowing what they were doing, and it can really end up in a mess.
I know I work at a large cloud provider, and I have worked at other ones before, but I'd still say with the state of Kubernetes right now, if you can, it's more secure to run it on your own hardware and your own data center in a non-multi-tenant environment, because I don't know that we really have good, secure multi-tenancy yet in Kubernetes. But if you do need to use a public cloud or many public clouds, still run, if you can, single tenant, right? Single tenant, probably implemented differently in different cloud providers, but don't share your control plane with anyone, with any other Kubernetes. Don't share your Kubernetes control plane with other users or other customers. It's probably the biggest vulnerability I've seen.
And to build on that, we're in a really exciting time where HPC really isn't developed yet to work on cloud native. So there's a whole bunch of work that can be done. There's a whole bunch of tools that can be done. We can imagine what we want it to look like. And as an example, we could start using the QAT cards as an accelerator for TLS so that you have faster crypto traffic. There's a whole bunch of things we could build just like that as an example to get this where it needs to be. but it's not where it needs to be yet. So you really can't run securely except in a single tenant environment at this time.
Yeah, I love that. I mean, that sounds so much like the spirit of open source. It's not quite ready yet, and that's great. That's the challenge we get to build. And Sarah, I feel like what you've said about, don't try to fake like you know it all. Don't think that, don't worry that you're expected to, whether you're super senior in your field or whether you're new to this. And I feel like that's really, really good advice. The great thing about Kubernetes is nobody's expecting you to know everything and nail it all. This is moving so fast. We're changing so much, and heck, nobody's been in this for 6 years. So there's yeah. I feel like this is really great. I feel like honestly, what I'm taking away from this panel is I've learned some, and I have a lot more to learn. So I'm eager to go learn and then see if I can contribute. Well, thank you very much.
Thanks, everyone.
Thanks, everyone.
Thanks, everybody. Thanks, Jay.
Bye.
Thanks.
Bye.
Bye.